This video will walk you through hypothesis testing using Excel. The hypothesis we're going to test here, there are going to be two of them. First, I want to test the hypothesis that the average return is negative 10%. So here we go. Hypothesis 1, average return is negative 10%. That's my first hypothesis, and then my second hypothesis is the average return is less than negative 10%. Okay, so those are the two hypotheses I'm going to be testing in this video. And again, I'm using the returns to data, and I'm picking up from where I left off. So I already have my histogram in here, my frequency distribution, as well as my descriptive statistics and my confidence interval. So let's start with the first hypothesis. If I believe that the average return is negative 10%, then HO is mu 0 equals negative 10%, and HA is mu 0 is not equal to negative 10%. The rule is that the HO always has to have the equals, and the HA is always the is not equal to. Now, since I'm looking at an equals or not equals test, that means it's going to be a two-tailed test. So I'll look at the p-value two-tail. So let's set this up as you've shown in the PowerPoint slides. I need the sample size, the mean, the standard deviation, the hypothesized value, standard error. Now, standard error, you don't technically need to do the standard error. It's just will help simplify my t statistic calculation, because the standard error is the standard deviation divided by the square root of number of observations. It just makes your t statistic calculation go a little bit smoother. So t statistic, p-value lower, or degrees of freedom, p-value lower, p-value upper, of course upper is spelled with a U. Spelling not my strong suit, sorry. You will notice that throughout the semester. And p-value two-tail. Alright, then let's just move this column width over a little bit, stretch that out. Okay, so I can go through and I can do my count function to get my sample size, or I can just link that here to my descriptive statistics where I've already, it already has the count of 83 as my sample size. I can use the average function to calculate my mean, or again, since I just have my descriptive statistics here, I can link right to there for my mean. I could use the stdev function to find my standard deviation, or again, I could just link right here to my descriptive statistics. My hypothesized value is negative 10%. Now notice all of this information is already in percentage notation, so I'm going to enter that as negative 10. My standard error is equal to my standard deviation divided by the square root of my sample size. And again, I'm getting that information right off of the hypothesis testing slides from Chapter 2. I'm doing the t distribution. So the t statistic itself is mean minus hypothesized value divided by standard deviation divided by the square root of the number of observations. So that standard deviation divided by the square root of the number of observations, that's the standard error. So that standard error is going to be the denominator of my t statistic. Now, the degrees of freedom here is going to be n minus 1. So again, I can just link to my sample size minus 1, or I could have typed in 82 in there. That's not that big of a deal. So my t-statistic is equal to my mean, minus my hypothesized value, that quantity, divided by my standard error. Okay, so my t-statistic is negative 1.67. Now again, note if you wanted to be following the formula explicitly, you could do, using additional parentheses, so mean minus your hypothesized value, that divided by that divided by standard deviation divided by the square root of the number of observations, as opposed to just doing that separately as a standard error in your denominator, and you'll note that you can't come up with the same result. So either way works if you want one less step involved in there. Now, notice I've come up with a negative t-statistic. In order to make sure that the t-distribution works and we're able to find our p-value upper and lower without having any kind of difficulty, what I'm going to do is always take the absolute value of this. Okay. Now, so my official formula is, as you will see in the Excel slides, the absolute value of the mean minus the hypothesized value, that quantity, divided by your standard error, where again your standard error is your standard deviation divided by the square root of the number of observations. Now, your p-value lower is going to be equal to t-dist, the test statistic you calculated, the t-statistic you calculated, comma, the degrees of freedom you calculate, which was n minus 1, comma, true. The p-value upper is going to be equal to 1 minus the p-value lower. And the p-value two-tail is equal to 2 times the minimum of the p-value upper and lower. Now, to test hypothesis 1, that is a two-tailed test, so I would look at p-value two-tail here. Let's highlight this. To test hypothesis 1, I'd be looking at p-value two-tail and my conclusion there. Now, remember, the way that I decide whether to reject or do not reject my HO is to look at my p-value. If p-value is low, reject HO. So what is low defined by? Low is defined by less than 0.05. So if this is less than 0.05, I'll reject HO. Here, 0.098 is not less than 0.05, so I do not reject HO. There is insufficient evidence to conclude that the average return is negative 10%. Or put alternatively, I am 95% confident that the average return is not negative 10%. Then for hypothesis 2, I wanted to test that the average return, I think that the average return is less than 10%. So when I'm doing hypothesis testing, I don't necessarily want to prove that what I think is correct. I actually want to prove that the opposite of what I think is correct is in fact incorrect, therefore making my answer correct. So kind of circular logic there. But since I think the average return is less than 10%, then my HO would be that the average return is greater than or equal to negative 10%. This tells me it's a one-tailed lower test, so I'm going to want to look at the p-value lower, and you can see there for hypothesis 2 testing that the average return is less than 10%. Oh, let's highlight that in a different color just so we can see the difference. There I'm going to look at the p-value lower, and that is in fact less than 0.05. So there I would reject HO. And I would say I am 95% confident that the average return is in fact less than 10%. So HO was the average return is greater than or equal to negative 10%. The reason that was my HO is because HO is the opposite of what you think should happen. I think the average return should be less than negative 10%, so I test that the average return is greater than or equal to negative 10%. I am now rejecting that the average return is greater than or equal to negative 10%, therefore concluding that the average return is in fact less than or equal to negative 10%. So reject HO. I'm 95% confident that the average return is less than or equal to negative 10%, or is not greater than or equal to negative 10%.